Welcome to Senior High School Math Series. This time let us have part 2 of the definition and equation of a parabola with vertex at point HK under PreCalculus Quarter 1 Week 2 based on curriculum implementation and learning management matrix for K-12's most essential learning competencies. Let us recall that for a parabola that opens to the right with vertex at origin and focus at C0, since the focus is C units away from the vertex, the axis is the x-axis and the latus rectum with length 4C and whose ends are at C, 2C, and C, negative 2C. The directrix is the line x equals negative c. The equation is y squared is equal to 4cx. We now consider a parabola whose axis is parallel to but not on a coordinate axis. In the figure, the vertex is at hk and the focus at the point h plus ck. We introduce another pair of axes by a translation to the point HK. Since the distance from the vertex to the focus is C, we have at once the equation y prime squared is equal to 4cx prime. To write the equation of the parabola with respect to the original axis, we apply the translation and thus obtain y minus k squared is equal to 4c times x minus h. We observe from this equation and also from the figure that when c is greater than 0, the factor x minus h of the right member must be greater than or equal to 0. Hence, the parabola opens to the right. For c is less than 0, the factor x minus h must be less than or equal to 0. And therefore, the parabola would open to the left. The axis of the parabola is on the line y minus k equals 0, or y is equal to k. The length of the latus rectum is equal to the absolute value of 4c, and hence the endpoints can be easily located. A similar discussion can be made if the axis of the parabola is parallel to the y-axis. Consequently, we make the following statements. The equation of a parabola with vertex at hk and focus at h plus ck is y minus k squared equals 4c times x minus h. The parabola opens to the right if c is greater than 0, and opens to the left if c is less than 0. The equation of a parabola with vertex at hk and focus at h, k plus c is x minus h squared equals 4c times y minus k. The parabola opens upward if c is greater than 0 and opens downward if c is less than 0. Each of the equations in the previous slide is said to be in standard form. When h equals 0 and k equals 0, they reduce to the simpler equations that we have discussed in the video lesson prior to this one, that is the parabola with vertex at the origin. If the equation of a parabola is in standard form, the graph can be quickly sketched. The coordinates of the vertex and the ends of the latus rectum are sufficient for a rough sketch. Plotting a few additional points would of course improve the accuracy. Also, let us note that the equations in the previous slide is quadratic in one variable and linear in the other variable. This fact can be expressed more vividly if we perform the indicated squares and transpose terms to obtain the general forms. We have x squared plus dx plus ey plus f is equal to 0 when the parabola either opens upward or downward. Y squared plus dx plus ey plus f equals 0 is the general form of the equation of the parabola when the parabola opens either to the right or to the left. Conversely, these two equations can be presented in standard form, provided that E is not equal to 0 in the first equation and D is not equal to 0 in the second equation. Let us have an example. Express the equation of the parabola x squared minus 6x plus 8y plus 25 equals 0 in standard form. Our solution is by grouping the terms with variables that appears quadratically on the left-hand side of the equation, in this case x, and also by transposing the terms with variables that appears linearly to the right-hand side of the equation, in this case y. So we have x squared minus 6x equals negative 8y minus 25. The next step is to complete the square in the quadratic expression x squared minus 6x. Since the leading coefficient of x squared minus 6x is 1, then we can complete the square by adding b over 2 squared to the left-hand side and the right-hand side of the equation. In the quadratic expression x squared minus 6x, b is negative 6, hence we have negative 6 divided by 2 is negative 3 squared, that is equal to 9. So we add 9 to both sides of the equation, hence we have a perfect square trinomial on the left hand side, x squared minus 6x plus 9. On the right hand side of the equation, minus 8y minus 25 plus 9. On the left hand side of the equation, the factored form is x minus 3 squared. On the right hand side, we have negative 8y minus 16. A common monomial, negative 8, can be factored. So we have x minus 3 squared is equal to negative 8 times the quantity y plus 2. And this is the standard form of the equation of the given parabola. Let us have the properties of the parabola with vertex at hk. For the parabola with equation x minus h squared equals 4c times the quantity y minus k, the vertex is at hk. If c is positive, the parabola opens upward, and if c is negative, the parabola opens downward. The focus will have the coordinates h, k plus c. The axis of symmetry will be the line x is equal to h. The length of latus rectum will be the absolute value of 4c. The ends of the latus rectum will have the coordinates h minus 2c, k plus c, and the other end h plus 2c, k plus c. Notice that the ends of latus rectum will have the same y coordinate as the focus. The directrix will be the line y is equal to k minus c. Let us have example number 2. Identify the properties and draw the graph of the parabola in example number 1. From example number 1, the equation of the parabola in standard form is x minus 3 squared equals negative 8 times the quantity y plus 2. Let us identify the properties after we solve for the value of c. From the equation, we know that 4c is equal to negative 8. Dividing both sides by 4, we have c is equal to negative 2. Hence, we know that the parabola opens downward. The vertex is at HK, hence we will have the vertex at 3, negative 2. The coordinates of the focus will be H, K plus C, so that will be 3, negative 2 plus C, that will be negative 4. Therefore, the focus will be at 3, negative 4. The axis of symmetry is the line x minus 3 equals 0, or x is equal to 3. The ends of LR will have the coordinates 7, negative 4, and the other end, negative 1, negative 4. The focus and the ends of the latus rectum will have the same y coordinates. 7 is obtained from 3 minus 2 times c, that is 2 times negative 2, negative 4. So we have 3 minus negative 4, that is 7. And also negative 1 is obtained from 3 plus 2 times negative 2. 2 times negative 2 is negative 4. So 3 plus negative 4 is negative 1. The length of latus rectum is the absolute value of 4c, so that will be 8 units. The directrix for this parabola is the line y is equal to 0. That is k minus c. So negative 2 minus negative 2, that will be equal to 0. Let us graph the parabola. The rectangular coordinate system. Vertex at 3, negative 2. The focus at 3, negative 4. The directrix. The axis of symmetry, that is x equals 3. And the ends of latus rectum. And finally, the parabola. How about if the parabola opens either to the left or to the right? So let us have the properties of the parabola with vertex at HK and the equation y minus k squared is equal to 4c times the quantity x minus h. The vertex is at HK. If c is greater than 0 or if c is positive, the parabola opens to the right. If c is less than 0, the parabola opens to the left. The coordinates of the focus will be h plus c, k. The axis of symmetry this time will be the line y minus k is equal to 0 or y is equal to k. The length of latus rectum will be the absolute value of 4c, and the ends of latus rectum will have the coordinates h plus c, k plus 2c, and the other end h plus c, k minus 2c. The directrix will be the line x is equal to h minus c. Let us have example number 3. Identify the properties and draw the graph of the parabola y squared plus 6y minus 4x plus 9 equals 0. The equation of the parabola is given in general form. To identify the properties, we have to translate the equation to its standard form. To do that, let us isolate the quadratic expression y squared plus 6y to the left-hand side of the equation by adding 4x minus 9 to both sides of the original equation. Notice that the leading coefficient in the quadratic expression is 1 and the coefficient of y is 6. Then we can complete the square in the quadratic expression by adding b over 2 squared to both sides of the equation. And since b is equal to 6, we will have 6 divided by 2 is 3 squared. That will be equal to 9. So we add 9 to both sides of the equation. The left side can be factored as y plus 3 squared, while the right-hand side of the equation simplifies to 4x. Now we can get the focal distance c by equating 4c to 4. Then dividing both sides by 4, we get c is equal to 1. C is greater than 0, therefore the parabola opens to the right. The vertex is at 0, negative 3. The focus will be 1 unit to the right of the vertex, hence the coordinates of the focus will be 1, negative 3. The axis of symmetry will be the line y plus 3 equals 0, or y is equal to negative 3. The length of latus rectum is the absolute value of 4c, that is equal to 4. The ends of latus rectum will be 2 units, or 2 times c is 2, 2 units above the focus, and 2 units below the focus. 2 units above the focus will have the coordinates 1, negative 1, and 2 units below the focus will have the coordinates 1, negative 5. The directrix will be x is equal to negative 1. That is 1 unit to the left of the vertex. Let us graph the parabola. We have the rectangular coordinate system. Then we have the vertex at 0, negative 3. The focus at 1, negative 3. The ends of latus rectum, the directrix, and the parabola. Let us have example number 4. A parabola whose axis is parallel to the y-axis passes through the points 1, 1, 2, 2, and negative 1, 5. Find its equation. The equation must be quadratic in x and linear in y. Hence, we will start with the general form of the equation. X squared plus dx plus ey plus f is equal to 0. This equation must be satisfied by the coordinates of each of the given points. Then, substituting the coordinates of each point, we will have 3 equations in 3 variables d, e, and f. We're going to solve the resulting equations simultaneously to get the values of d, e, and f. Substituting the point 1, 1 to the general form, we will have 1 squared plus d times 1 plus e times 1 plus f is equal to 0. So we have d plus e plus f equals negative 1. Let us call this our equation 1. Substituting the point 2, 2 to our equation, we will have 2 squared, that is 4, plus 2 times d plus 2 times e plus f is equal to 0. Then we have 2d plus 2e plus f equals negative 4. Let us call this our equation 2. Next, let us substitute negative 1, 5 to the equation. So we have negative 1 squared, that will be 1, plus d times negative 1, so we'll have minus d, plus e times 5, so we have 5e, plus f is equal to 0. So we have negative d plus 5e plus f equals negative 1. Let us call this our equation 3. So we're going to solve equation 1, 2, and 3 simultaneously to solve for d, e, and f. Our solution is by elimination by addition or subtraction. Let us first eliminate the variable f. So we will have equation 2 minus equation 1. So we have 2d plus 2e plus f equals negative 4 minus d plus e plus f equals negative 1. We're going to subtract the two equations term-wise. So we will have 2d minus d, that will be equal to d. 2e minus e, that will be equal to e. And then f minus f is 0. And then negative 4 minus negative 1, that will be negative 4 plus 1. And that is negative 3. Let us call this our equation 4. Next, let us have equation 2 minus equation 3. So we will have 2d plus 2e plus f equals negative 4. And then we have negative d plus 5e plus f equals negative 1. Subtracting these two equations term-wise, we will have 2d minus negative d, that will be 3d. 2e minus 5e, that will be negative 3e. F minus f is 0. Negative 4 minus negative 1, that will be negative 3. All terms can be divided by 3, so we will have d minus e equals negative 1. Let us call this our equation 5. By equation 4 and 5, we have already reduced the three equations into two equations in two variables. Let us eliminate e by adding the two equations. We have equation 4 plus equation 5. So that will be d plus e equals negative 3 and d minus e equals negative 1. Adding the two equations, we will have 2d e plus negative e equals 0. Negative 3 plus negative 1 is negative 4. Dividing both sides of the resulting equation by 2, we now have the value for D that is equal to -2. Now that we have the value for D, we can choose equation 4 or equation 5 to get the value of E. Let us choose equation 4. That will be -2 plus E equals -3. Adding 2 to both sides, we will have E is equal to -3 plus 2, that will be -1. Now that we have the values for D and E, we can choose either equation 1, 2, or 3 to get the value of F. Let us choose equation 1. So we have D plus E plus F equals -1. Substituting the value of D and E, we will have -2 minus 1 plus F equals -1. -2 minus 1 is -3. Then adding 3 to both sides, we will have F is equal to 2. Now that we have the values for D, E, and F, we can go back to the original equation in general form and substitute the values of D, E, and F. Hence, we will have x squared minus 2x minus y plus 2 is equal to 0. Let us have another example. Find the equation of the parabola with vertex at 3, -4, axis horizontal, and passes through the point 2, -5. We are given the vertex at 3, -4, and the axis is horizontal. Therefore, we can use the standard form of the equation of the parabola. Y minus k squared is equal to 4c times x minus h. We can get the value of c by substituting 3, -4 to hk and 2, -5 to xy. Let us do that. We will have -5 minus -4, so that will be plus 4 squared is equal to 4c times 2 minus 3. -5 plus 4 is -1 squared, that is 1. 2 minus 3 is -1. So we have 1 is equal to -4c. C is equal to -1/4. Going back to the standard form of the equation of the parabola, substituting the value of c and the coordinates of the vertex 3, -4, then we have the equation of the parabola in standard form as y plus 4 squared is equal to 4 times -1/4, that will be -1 times the quantity x minus h is 3, x minus 3. This time, let us have some practice exercises. In the practice exercises, you will be given 15 seconds to answer the item. You may pause the video if you need more time to answer, and then play it again to check whether your answer is correct. Let us have number 1. Find the equation of the parabola with vertex at 0, 3 and focus at 4, 3. Go! Time is up. Let us see the answer. Notice that the vertex and the focus have the same y coordinates, that is 3. Hence, the axis of symmetry is a horizontal line parallel to the x-axis. Therefore, we have the standard form of the equation of the parabola as y minus k squared is equal to 4c times x minus h. The coordinates of the focus is at h plus c k, and this time it is at 4, 3. Therefore, we can equate h plus c is equal to 4. And since the vertex is at 0, 3, h is equal to 0. Therefore, c is equal to 4. Then substituting the value of c and the coordinates of the vertex to the standard form of the equation of the parabola, we will have y minus 3 squared is equal to 16 times x minus 0, that will be x, or 16x. Number 2, find the equation of the parabola with vertex at -1, -2. The length of latus rectum equals 12, and the parabola opens downward. Go. Time is up. Let us answer. Since the parabola opens downward, then we have the standard form of the equation as x minus h squared is equal to 4c times the quantity y minus k. The vertex is at -1, -2. Therefore, the vertex hk is at -1, -2. The length of latus rectum for C is equal to 12. And it opens downward, then C is less than 0. So we have the equation x minus -1, that will be x plus 1 squared, is equal to 4c, that is equal to 12, and the parabola opens downward, so we have -12 times the quantity y minus -2, so we have y plus 2. The equation of the parabola is x plus 1 squared equals -12 times the quantity y plus 2. Let's proceed to number 3. Identify the properties of the parabola x squared minus 12x plus 16y minus 60 equals 0. Go. Time is up. Let us start by translating the equation to its standard form. So we have x squared minus 12x to the left hand side of the equation. Then add negative 16y plus 60 to both sides. So we will have negative 16y plus 60 to the right hand side. Completing the square in the quadratic expression, we have negative 12 divided by 2, that is negative 6. Squared, that will be plus 36 to both sides of the equation. The left hand side can be factored as x minus 6 squared. The right hand side simplifies to negative 16y plus 96. Negative 16 is a common factor in the terms on the right hand side. So we have x minus 6 squared is equal to negative 16 times the quantity y minus 6. Hence, we can get the value of c, or the focal distance, for c is equal to negative 16. Divide both sides by 4. C is equal to negative 4. C is less than 0, therefore, the parabola opens downward. The vertex is at 6, 6. The focus will be 4 units away from the vertex. Then we have the focus as 6, 2. That is 4 units below the vertex because the parabola opens downward. The axis of symmetry is the line x is equal to 6. The length of latus rectum is the absolute value of 4c, that is equal to 16. The ends of the latus rectum will be 2 times c units to the left of the focus and 2 times c units to the right of the focus. So we have the coordinates negative 2, 2 and 14, 2. The directrix is the line x is equal to 10. That is 4 units above the vertex. Exercises on this topic may be downloaded from the description of this video. That will be all. Thank you for watching. Please subscribe for more math lessons.